Hey, OChemsters, this is Mrs. Vando bringing you more OChemster video. So right now, you should have already finished your practice. And so now I just want to go over the answers with you. So like we did before, we went through and said SN1, you have either a primary or a secondary substrate, and you have a strong base, usually an anion, a negatively charged base. And that's pretty consistent with SN2. SN1 is a secondary or a tertiary substrate, and you have a neutral base. Okay, so not strong, but fairly weak. Remember, SN1, you have to wait for that bromide to leave, and so it could just be mildly attracted into the carbocation that results. With SN2, you need a strong base to force that bromide or whatever halogen you're using to leave. So that's why you need that. So let's take a look at right here. It says using the table found in 6.2. I hope you used that, by the way. Write out the full equation for the following, okay? Then label as SN1 or SN2. So the first thing we had to do is look at the 1-bromobutane. So here's my 1-bromobutane, okay? So here I have a sodium and my iodide. Don't forget here, what's going on? Is my sodium going to do anything? No, it's a spectator. Leave it out. Don't even put it into the equation, all right? The only thing I'm really interested is the iodide. That is my nucleophile, and that is found on, I think, page 3 in your note packet, okay? So before we figure out what my products are, what kind of reaction is this? Well, this carbon right here is primary. There's only one carbon off of it. There must be 2 hydrogens hanging off of the carbon that didn't draw it right in. What else is consistent? This is a negative anion, all right? So this is all consistent with SN2, okay? So I'm ready to begin, and what's gonna happen, I'm gonna simply swap out my bromine, and my bromine leaves, and the iodine takes its place. Fairly straightforward, I would think. Okay, so what about the next one? N-propyl iodide. Okay, well, here's my normal propyl iodide, normal meaning it's straight chained, and my iodine's at the end. So this time my iodine is the leaving group. And now I'm going to have sodium acetylide, all right? Well, where did I find that? Well, oops, sorry, page 2 and 3. All right, just like they told you up ahead, page 2 and 3 told you what the acetylide is, all right? So it's a triple bond. So am I worried about the sodium? Of course I'm not worried about the sodium. What do I say about the sodium? It is a spectator ion. So I'm only worried about this negative ion here. So before I begin, hey, what kind of reaction is this going to be? I have a primary substrate, and I have a negative nucleophile. So that is going to be an SN2 again. Well, pretty straightforward. All right, the iodine leaves, bye-bye iodine, and then the acetylide takes its place. So how would I name this product? All right, it looks like it's a 1-pentyne, isn't it, with that triple bond there, triple bond, excuse me. Well, what about the next one, this allyl chloride? What the heck is an allyl chloride? You might have had to go back into chapter 2. I know, it's a long time ago. And look up what allyl chloride is, all right? It's an old-fashioned way of saying I have 3 carbons of a double bond and then a single bond carbon off of that. So my chloride comes off with a single, all right? I would have probably called it 3-chloro propene, but that's okay. Allyl chloride also works. Now, look at this. What is ammonium? You might have had to look that up. Ammonium is NH4+. This is Willie. You have a typo. Yes, you are right. I have a typo. You can't have a positive nucleophile, okay? Ammonium doesn't work. So let's keep going, see what else is wrong. So if I had ammonia as an NH3, that's a neutral weak base. Does a primary substrate and a weak base work out to be anything? You might think, well, if it's a weak base, it's SN1, but I have a primary, so it would be SN2. Folks, Mrs. Vanley goofed, and I don't know what I meant to do, so we'll just leave that one alone, okay? So let's look at letter D. 1-methyl, 1-bromo, cyclohexane. when you're doing these problems, I would highly recommend you show the chair configuration here, okay? Now, do I have to worry about cis and trans in letter D? And the answer is no, I don't. Well, why not? Because I have both things coming off of the same carbon. All right, this is not where I have two things on the same side, all right, or on opposite sides. So let's not worry about that, okay? So this is just plain old, you know, one methyl, one bromocyclohexane. Hey, look what I can do. I still have one methyl, one bromocyclohexane, all right? So if I flip it around, it's still the same thing. So yes, cis and trans don't make any difference, okay? And now what else do I have? I have methanol. So if you remember how we wrote methanol, you have a one carbon, that's your meth, and then your OL is your alcohol, your OH group, all right? So there is your methanol. Now, what kind of reaction is this going to be? Well, what kind of a carbon is right here? How many carbons are on this carbon? I got 1, 2, 3. That's a tertiary, isn't it? What do you notice about my nucleophile? Is it an anion? No, it's neutral. It's a weak base. Alcohols are going to be like a weak base. So is this SN2? Nope, it is truly SN1 without any doubt in my mind. All right, so what am I going to get? I want to show you something, okay? Let's go to the very front page. All right, here's our front page, and I want to go here. All right, so what happens when my nucleophile is neutral? What kind of organic product do I get? I get positive, don't I? Why? Because a neutral and neutral is neutral. My leaving group is always negative no matter what. My organic product has to be positive. All right, and I wrote that down here. If a nucleophile and substrate are neutral, then the organic product will be positively charged. Let's go back and look at the problem again. All right, so I need to have a positive organic product, okay? So what happens? It's the oxygen that is attracted to this carbocation that is remaining, all right? Because remember, in an SN1, the bromide leaves first. Okay, so the bromide is gone, and now you have a positive carbocation, which the oxygen, being electronegative, is going to be attracted to. But once it bonds here, what's up with this oxygen? How many bonds does oxygen have? It has 3 bonds. Well, how many bonds is oxygen used to? 2. So if oxygen has 3 bonds, it's going to be positive. If oxygen has 2 bonds, it's going to be neutral. So what do you think can happen? Now, let me just say this. If you want to, for me, for Mrs. Vanderwall, I don't know what your college professor is going to want, but if you want to stop this here and say, this is my final answer, I'll be okay with that. But for some of you, like, ooh, that looks weird. All right, if you want to go on to one more step, what could you do? You could take off, let me please back here again. You could take off the H plus, all right? I need to put, here we go. Take off the H plus, all right? And then here, of course, is your leaving group again. So I took off this. The positive can be then given to the H, so it's donating, it's, the H plus is leaving. And then here is that bromide hanging around. And is this still going to be neutral? Yes. So this right here, my organic product, is still neutral. And an H plus and Br minus is also adding together going to be neutral. So either one is going to work. And I don't care which one you use. Your college professor might, but I don't. Okay, I'd be happy if you can do this. Okay, let's look at letter E next. Okay, so I have 2-chlorobutane. Okay, here's my 2-chlorobutane. It's secondary. Something else should start ringing bells. Are the same exact things off of this carbon here. I have a hydrogen, I have a 1 carbon group, and I have a 2 carbon. Oh, that's R and S, isn't it? So take your H, go to your next smaller one, that's 1 carbon, and then go over here. Hey, what kind of direction am I going when I circle around this way? I'm going in the counterclockwise. That's an S. That's sinister, isn't it? All right. Okay, now what? This is really important. This is so important. I have sodium ethoxide. What the heck is that? Well, if you looked on the chart on page 2 and 3, like the directions told you to, you could have figured that out, okay? So am I going to worry about my sodium? No. All right, all I'm worried about is my negative anion, my negative nucleophile. So right now, because this is secondary, you can't tell me SN1 or SN2 based on secondary. So what do you have to do? You got to look at this. This is negative. That's why it was so important. So if I have a secondary and a negative nucleophile, then what is it? It's SN2. Why is that important? Because how many different organic products am I going to have? One. I will 100% of the time invert this. So if you start out with S, you're going to end up with R. Now let's just play pretend. What if this was neutral? And therefore it's SN2. I'm sorry, that was dumb. SN1. How many organic products are you going to have? You're going to have two. You're going to have 50-50. You're going to have half R and half S. But that's not the case. That's why this is so important to identify what kind of reaction it is so that you know, in this case, I only have one organic product and it must be the R version. So let's check this out. This is what I came up with. All right, so you know what? This is kind of weird. I left off, oh, here's my chlorine, silly Mrs. Vanderlei. So my chlorine group is over here. And now what? I have A, B, C. My nucleophile doesn't count in this, right? A, B, C. What direction am I going? A, B, C. I'm going clockwise. That is rectus. That is right. That is R. Okay, so I had to have my inversion in an SN2. Did you catch that? Okay, let's go on. Let's look at letter F. P-chlorobenzyl chloride. Holy moly, what the heck is that? Well, what's a benzyl chloride? All right, this, without the chlorine there, is your benzyl chloride. All right, that's your benzyl chloride. So then I have para, which means on the opposite. Now, what did you notice about this? I have a group on 1 and I have a group on 4. So I have to worry about cis and trans. Well, they didn't tell me what this is, okay? So when I drew it first, I made it cis. If you want to start your reactant being trans, go for it, okay? But now what? This is important, all right? Sodium cyanide. What did I tell you about sodium? It's Na+. It's a spectator. So what is cyanide? Oh, this is so important. Are you writing this down when I say this is so important? I hope you are. What do I know about cyanide? It is a negative anion. So this carbon is the one I'm going to be looking at. Okay, right here. Is this primary, secondary, or tertiary? It's secondary, isn't it? Huh. So this over here is going to determine whether it's SN1 or SN2. So if it's negative, just like the problem above, this is SN2. So what does that mean to you? Because it's SN2, 100% of my organic product must be what? Did you say it out loud? I didn't hear you. Must be what? It must be trans. Okay, it must be trans. Okay, and don't forget you have your chloride as your leaving group. Now, let's play pretend one more time. What if this were neutral? What if this were water? Okay, if this were water, what would I have had to do? I'd have to have 50% trans and 50% cis. Okay, that's again, I'll say it again, why it's so important to know if this is SN1 or SN2 to know how many products you have. Okay, let's go on. We're having so much fun. 2-chloropropane. All right, here it is. Now, do I have to worry about RNS? No, I don't, because this carbon is identical to this carbon, so I don't have to worry about this. Now I have sodium hydrogen sulfide. All right, my sodium is my spectator ion, so here's my hydrogen sulfide. Oh, it's negative again. So this is secondary, and this is negative. Do I have to worry about cis or trans or R and S? And no, I do not, all right? It is SN2, but no, because these are the same things, okay? Don't have to worry about it. So I'll just do this, and this is pretty straightforward, and there I All right, let's look down here now. Okay, so 1,4-dibromobutane. There it is. And lots and lots and lots of sodium cyanide. All right, so I know I have excess. Huh, what do you think I'm going to do? Twice. I think I'm going to substitute twice. Now, is this SN1 or SN2? I have primary here, negative, dead giveaway. No doubt in my mind it's SN2. So what am I going to do? I'm going to do this, and I'm going to substitute. I also knocked off 2 bromides. Okay. So let's look at this last one on this page. All right. So, what kind of carbon is this right here? I have 1 carbon, I have 2 carbons. This is secondary. Oh, so it's going to depend on my nucleophile, which is sodium cyanide. The sodium is positive, so so this is going to be SN2. Now, what else do I have to worry about here? I have to worry about R and S, don't I? Yeah, I do. Let's see. I have A, B, C. That's R, isn't it? So because it's an SN2, what's the only kind of product I'm going to have here? I have an S. So notice that my H and my C kind of flip-flopped. The only way I can make this, so put the C here where the H is, and then my cyanide took the place of the chlorine. So now I have A, B, C. All right, that's your S. And don't forget, you have a leaving group. Well, it seemed like this front page had an awful lot of SN2s. Let's go in the back and see if we have any more SN1s waiting for us, all right? All right, so here's my first thing, and notice it's in the chair again, and I have an HS negative. So this carbon is the one I'm looking at. There's your bromine. All right, is this going to be primary, secondary, tertiary? It's secondary. Oh, so now I have to look at this. Once again, it's negative. So we're getting a lot of these. SN2, it's probably the easiest one, I think. So now what do we have to worry about? I added a little carbon over here. Did you notice that? Because I have a bromine here and I have a carbon here. So these are in the cis position. They're on the same side. So what will my answer have to be? It has to be trans, all right? So I'm going to do that. Oops, I just covered it up. Here we go. So I'm going to make it trans. Here's my carb. Oops, where'd it go? I lost. Oh, I know it happened. There it is. All right, so I can put my carbon here. Now what? All right, I need my bromine as my leaving group. And where does my SH going to go? All right, where is it going to go? Well, I need it to be trans. So is it going to be on top? Yep. All right. And then my hydrogen is going to be on the bottom. And then I have a bromide leaving group. See if I can't find my H. And there we go. I made it the H there. Okay, phew, we made it. All right, what about the next one? All right, well, let's take a look. We have this thing. So again, it's in the chair position. Now, what do you notice about this one? You also have a second, I'll put a little 2 here, a secondary carbon because I have 1, 2 carbons off of here. And I have a negative ion, so I'm really on this SN2 kick, aren't I? So now what's going to happen? What do I have to do? Do I have to worry about inversion? Not at all. Why not? There's nothing for it to be cis or trans with, so it makes absolutely no difference. So I just, swapped it out, and then don't forget my leaving group. Okay. Well, what about letter L? So what's happening right here? I see this is a tertiary. Oh, and I have neutral, don't I? So it is SN1. And do I have to worry about inversion? No, but what do I have to worry about? If I have a neutral and my leaving group is negative, what's going to be my organic product then? It's going to be positive. So there it is. Here's the oxygen that is attracted to the carbocation that was created. Okay, and so oxygen has 3 bonds, which means it has a positive charge. Now, if that bugs you, it kind of bugs me. All right, what did I do next? I dropped the H plus off because I like that better. And then there's your bromide. Okay, so there you go. Now what? Part 3. You are given the organic product each time. Oops, sorry. neutral. You're given the organic product each time, so come up with your substrate and your nucleophile that will give you that organic product. To me, this is pretty easy. All I did is take 3 carbons and stuck a bromine on it. Now, this is neutral, isn't it? So what must be my nucleophile? If this is neutral, my nucleophile must be negative. All right. So for the next one, I just took, you have either 2 carbons here or 2 carbons there. You really can't go wrong with 2 carbons. All right, I stick a bromide because it's easiest. And then this is neutral. What must my nucleophile be? It must be negative. All right, and there you go. All right, I see this acetylide again. So I'm going to make this my nucleophile. All right, here it is. And then these 3 carbons are my substrate, and voila. All right, so this next one, I have 3 carbons. I'm going to make my life a little easier here. And then I have an O and a CH3. Again, if this whole thing is neutral, my nucleophile must be negative, okay? Finally, I have some of these crazy things. My cyanide is my nucleophile, so I made my bromide here, and then my cyanide. You do know that cyanide is kind of a poison, right? Don't play around with cyanide. You really don't want it in things like your yum yum sauce or anything. So yeah, just don't worry about your cyanide. But anyway, this would be your nucleophile, and here is your substrate, okay? And last but not least, we have this next one where here is my, whoops, I left off something, didn't I? Let me fix that. All right, and then finally, I have this, and voila, those are my substrate and my nucleophile. So I hope this really helped. And so hopefully you did well. This makes sense. If you have any questions, please let me know. And don't wait to be great. We'll see you next time. Bye-bye.